Hi, I'm Tsahi Levent-Levi of blog.me, and this time I want to talk about your global reach. Where exactly is your application going to be used? We've talked about devices, now we look at the infrastructure and geographies a bit. Now, whose map is this one? Well, the answer is AWS, Amazon Web Services. The dots that you see on the map are actual locations of their data centers today. And if you want to run your service in South Africa, there is nothing close by to you. So you can't really use AWS, or you can, but expect some more latency in the service itself. What I'm trying to say is this. Global reach doesn't equate certain data center or certain cloud provider like AWS. It ends up depending on your user base and where they are located. Now, even if the servers are located where you need them, you might have some certain issues. And let's see this as an example. Let's say we've got a user in Europe that wants to join a group call. He is going to connect to an SFU, a media server, close to his location in Europe. And he is connected first, so that's where the SFU is assigned. Now we've got 3 more participants joining this call, and they are coming from the US. They will join the same SFU, and that's it. Now the problem here is that when you look at it, the route that the media does from these 3 participants is quite long. So there might be a lot of more packet losses than there should be, more jitteriness of the network, more latency, just because of that. And remember, we're not in control of the network, and at least not of that network. So what can we do to mitigate that? We can do the following. The user now joins his SFU locally in Europe. The service now sees that there are additional participants that want to join, but they're located elsewhere, in the US in this case. So it's going to assign another SFU close by to them. They are going to connect to that SFU, and now these 2 SFUs are going to interact directly between them to send the data for this session. We call this cascading, and this does something very interesting. Now all users use a network that is close to them in order to get to the media server, and then what goes on between the media servers is under our control. It's in networks that we can pay more in order to get better bandwidth or better quality. Okay, so we added more control into our system simply by cascading. How is that done exactly? If we have, for example, 4 participants in the service, and we have a single SFU, all of them are going to send the media towards the SFU, and the SFU will route the media back towards them. We've seen that already. What we want to do now is look at the same scenario, only with participants that run in different geographies, in different locations. And let's say we've got 3 of them, 3 locations and 4 participants. So our user is going to send the media towards the SFU that is closest to him. That SFU is going to send the media to users that are close to him, or to servers that serve the other participants. This is going to look like this. Now, all users in this session are going to do the same. They will send their media towards the SFU that is closest to them, and that SFU will route the media either to other users that are close by, or to other SFUs that serve the other users. So that's cascading. So look outside the AWS data center box. Okay, think what you need to do to achieve a better quality by the infrastructure itself. Check if the live video platform that you are using supports cascading as part of the solution. Is this something that is there out of the box and is handled automatically? And also check what geographies are covered by the live video platform. Are these enough for your application? Make sure to check these 2 things because they will affect the quality of your service. So that's it for now, and see you in the next session of picking a live video platform.